Okay, so you notice that Inspector provide additional materials on how to use R for Arima model. So this one I provide recorded lectures in the more later. So next week we're going to spend time or to use time next week for your quiz. Okay. So this one is optional, but it's good for you to know how to use R, how to implement Arima. So exam will not cover this one. I mean, if I remember correctly, exam the outputs given, information given only if you use output. If I remember correctly, but I will check again. So I will update you later. If it is not true, so you can. So later you watch this video. So how to use R to implement Arima model. So the tests available in test, and then ACF, PCF, then how to estimate model, Arima model, and in the end it also explains how to use Auto Arima, automatic model selection. Okay. Using Auto Arima function. So Auto Arima. So meaning that the model will select the model automatically based on AIC or SIC, but remember that selection of using AIC and SIC is not necessarily will suggest model that is adequate. If let's say the model suggests after you use Auto Arima, you use automatic model selection, you have to check, you have to perform DNS checking to check whether residual whiteness or not. If not whiteness, then you have to consider an alternative model, because this one, the chosen model is not always adequate. Okay. So in EViews also we can choose model automatically. The same data, for example, I show example the same data that we used just now, lab session 10. Let's say this is our model, this is our data, and we want to select model automatically. So we go to view, prompt, automatic forecasting, Arima forecasting. Okay, and but as mentioned before, if you only consider non-seasonal difference, it does not consider seasonal difference. So unlike Auto Arima in R it will consider both. So let's say if the series is seasonal data, and then it will apply seasonal differencing. But if it's different, if it's only what we call that, if you use this one, then it will only consider non-seasonal difference. Okay, so with the maximum allowed up to 3 by default 2. And then the seasonal AR, seasonal MA, this one you have to decide. Let's say you allow to up 6, for example, then you can put, the default 4. Let's say you put 4. If let's say the seasonal AR2 as seasonal MA2, you put the maximum. Normally we put one. Normally we just allow one. We don't want to have too many. Okay. Order or parameter order to high order. So let's say we put maximum 2. Okay. And then you just click none. Let's say you want to apply log. Okay. We want to use our data. You want to apply log, you put log. You click this one, or you select log. Or you put auto, it will decide for you none or log. And then just okay. Then will select model for you. But so you provide this estimate. Selected model Arima 1120, which is applied on the non-certain difference series. Okay. So you can estimate lah. You want to get other statistic. You want to check whether the model is adequate or not. For example, then you can really estimate. So this one, for example, you will estimate. So this one ARIMA. So it's actually equivalent of having ARIMA 111 if PDQ because we apply differencing once. So ARIMA 111 and then 200. Okay. This one selected ARIMA on the different series. Okay, so basically ARIMA 111 200. And then it has non-zero mean regresses C. If you re-estimate the model, okay, we re-estimate estimate equation. So we have y d bracket y, and then we have C, and then we have ARIMA ER1, ME1. And then we have SAR2. How to know whether this is the same model? You compare lah, your AIC, you get exactly the same AIC, then you estimate the same model. Okay, this one AIC value. So if you are able to get the same, then it is the same model. Okay, so this one selected model. Okay, so your AIC, same right? 25.9994490. Okay. So this one, just the inverse idea are very close to 1. This one I think very close to 1, although it's not equal to 1. So if you check residual, okay lah. Okay lah. That model selected automatically lah, instead of you having to inspect the kilograms and identify potential model. But for the assignment, I would like you to explain. You do manual approach. Don't do the you want to provide additional, you want to make comparison, okay lah. They say you do the manual approach by manually identify, and then you want to compare with the result of with the model that selected automatically, okay lah. You can make comparison. Okay. But do not only present the result of model selected automatically, because I want to see whether you understand. Okay. So if select automatically, everyone can do that. I mean, they can use even auto ARIMA in R. Everyone can use that one. Okay. So we want to know whether you understand. You really understand what you are. So Bryce, Simon, so this one make sure if you all of you have already have a group, so don't suddenly submit a report only for one person. So we go through for the test first, midterm test. So for question number 1, you are given you are given the data in the EVS file. Inspect the time plot and season, describe the type of trend and season variation as well. So Q1. So you inspect the graph and then you describe. So in terms of seasonal, this one is a quarterly data. If you check cologram, for example, so you can see that leg 4, leg 8 high value significant. So it indicates present of seasonal. And then looking at graph that you can see it has. So this trend is just like quadratic. So you can see that just like quadratic. I mean, it's not linear, it's not straight. That's non-linear. Trend and seasonal additive. Seasonal can be considered additive. Okay, can be considered. Because it doesn't, I mean, if the quantitative is supposed to have consistently increase at the level increase, then the size. Just like inline data, you remember the one method. B, estimate and compare two regression model within trend and correct trend and choose one model and include the dummy if necessary, because it has seasonal variation, then you have to include the dummies. Okay, so some of you, I remember some of you did not just include time trend without the dummies, but you should include this one as well because it has seasonal variation. Okay, so to include the dummies, then you have to estimate model. So you have trend, so this quarterly data. So quarter instead of month. So this one, linear model. So you can save as equation 1, and then you estimate as a model quadratic. So you have a y space quarter. Okay. And then you compare. So which one? So quadratic trend has smaller value of AIC as I see, so we should choose. So you explain that. So basically we choose the quadratic trend model with seasonal dummies as it has smaller AIC and SIC. So notice that the next question says what? The next question says that assume that the chosen acidic model is an adequate model. Why? Because it's actually not adequate. You expect this one is not adequate because the Wilson low. And then you check chronogram or residual. It is not adequate model. Okay, so basically, if you want to perform seasonal partial test, for example, then you should fix the problem first. So maybe by adding RMI errors. So you can try what let's say ME1 for example, if let's say you consider this one is decreasing, for example, this one ME. So basically the lag 5 is significant. You can try that. So you can try let's say ME1. But this one is not, because that time we haven't discussed regression by RMI errors. So no need that time. I mean I will not expect you to do that at that time. Okay, but let's say in practice, I mean in actual and real practice, you should try to improve the model first. Okay, before you perform the seasonal variation test. For example, for your glucosamine whether it's possible. Okay, you want to perform the video test, seasonal variation test. So you should, in order to get valid or reliable result of the test, result of the hypothesis testing, then it is good to make sure the model is adequate model first. If let's say I simply put ME1, whether it's equal to 1.79, whether you can make it, so okay, now this one. Okay. There are other possible model available, but if let's say we just put ME1 also is already able to make better model, so that when you perform seasonal variation test, and then you are able to get more reliable result of hypothesis testing. So to perform the test here, you just test coefficient number 3, 4, 5, 6 equal. Okay, equal. So for example, I will show you the mock test coefficient number. So 3, 4, 5, 6 equal. Then okay. So you conclude that there is a seasonal variation. But again, for the test, I do not expect you to do this because at that time we haven't learned. So meaning that by assuming that the model is adequate, and then this one again. But in practice, in actual situation, you should try to improve the model. So assume that the chosen model is an adequate model. If used to produce point forecast. To point forecast, you just go to, because this is the chosen model 2, corrected trend model. So you go to forecast, YF. So this one, I need to calculate the interval, right? So just produce point forecast for the next 4 quarters. So YF, money is here. Point forecast of this. So 2010 first quarter, 2010 last quarter. Very easy, right? You should be able to do it. Very easy. Okay, so you get your forecast. This one you produce using this one, but the question asks you to calculate manually. So it's given here in the Excel file. It's based on the estimated equation. Then you have a beta 0 t plus beta 1 t plus beta 2 t square. Okay, and then this one intercept 335. Okay, that one the seasonal. So the first quarter 335. So second quarter you have to take the second one. Second quarter you take this one 172. Third quarter 83. So the other part you just change the value of T 37, 38, 39, 40. How to know the T? You refer to this one. So we have how many sample size? We have 8 sample. We have 36. So one step ahead 37, two step ahead 38. Okay, so on. D use to obtain normalized indices through classical composition of values. So this one you have the series classical composition. You go to prop seasonal adjustment moving average method, considering the additive seasonal variation, which is like additive, and then YSA factors you want to have to get the normalized indices. You can say this one. So let's say ST okay. So this one. So D, so the one D, E. Now E, use to automatically select an EDS model, show use output, produce point forecast. This one you can just use the one produced by the user and calculate an APE. So okay, this one here. So this one you can just go to prop export smoothing ETS. So auto, everything auto, to automatically select. So your forecast values, if you so YSM you forecast one step ahead, two step ahead here. This one you produce this one. Your forecast values. So okay. So you see, one of the problem of the disadvantage of using automatic select for the selection. So this one is because automatic model selection is select model based on AIC. So it's not necessarily just model that's able to capture the trend. But this one for this data, number one, because in this case the data is now it has quadratic trend, which is if ETS, it is a so basically we don't have that the type of trend that is suitable for quadratic, but if actually the best one maybe the multiplicative trend, but it's slightly different to quadratic. It's just like quadratic, multiplicative trend is similar to the, it is like exponential trend. Quadratic is slightly different. So meaning I just remember so if when you choose model automatically later for the assignment as well, you notice that you select model without trend as well. You remember that one assignment, you do assignment, although it has trend. Okay, the series seems that actually the series you need to inspect the series, the graph you can see it has trend, but the model select. So sometimes it is better to select model by looking at the graph as well. Okay, maybe it's better than by inspecting the graph to see whether it has trend or not. Then you decide. So this one basically if you, so this one if you the forecast value given here, forecast value for the next 4, okay, and then you can calculate MAPE forecast MAPE 24.90, which is larger than the first model regression model, which is the 112. So the first model is 12.8 MAPE, but ETS 24. So meaning that the first model is better, regression model. But this one, why it perform only because of that one? Because it's like model without trend, but this actually has trend. Okay. Okay, so and then number 2. So number 2, give the data given in the Q2 use file. So inspect the program of the series, just a pure moving average. So this one we assume the series already stationary. So at that time we haven't discussed the stationary test. So inspect the program, suggest a pure moving average model to this calculation and new justification, set maximum order, allow up to 6 for the MA process. So we have the data here, assuming the data already is stationary, so we inspect the program of the series level. So for pure MA, you have to inspect this one. Okay, sample is F. So it is the last significant one is leg 2. So MA2 by assuming that the true PCF exponential decay. Estimate the proposed model, inspect the inverse roots of MA parameter and make appropriate conclusion and determine whether the model is adequate or not. So estimate the model, MA2, quick estimate equation. So we have Y space C space MA2. Okay. So C significant you need to have C. So if you do not have C, then you will not get full mark. And then inspect the inverse of the MA root. So view Arma structure. So this one, or inverse of the MA root inside the circle, and then in terms of conclusion, we see that the model is invertible. The estimated model is invertible. And then show manual calculation. If you produce forecast, you get, for example, if I make two parts the same number, AR you get slightly different. Just now we estimate the model. How to calculate manually? The one given in the Excel file. Q2 calculate. So recall the formula. So C give us estimate for mean. So the constant itself is just the mean. So the mean plus theta 1 epsilon t minus 1 plus theta 2 epsilon t minus 2. So the forecast based on the equation. Okay, so you have, so no need, number one, no need to have the, so you have, this one you can get from, this one, you go to view, actual predicted table, so you have the residual, the last residual. So, and then you calculate, okay, using the estimated value of mean, and then theta, the previous residual plus theta 2, the last two residual. Okay, and then actually you can get from EViews. So you produce forecast using EViews, forecast. So this one again, I just want to show, I just want you to see how, whether you know how it is calculated. So again, because this time the exam has less calculation, but don't expect there is no calculation at all. Don't expect there is no calculation. There's some calculation, but not as much as before this time. So this time is this is a suitable time for you to pass. If you fail before. Okay. So if you fail again, I think no need to take this course again. Okay. If you learn, so but I don't think, I'm not sure. So yeah, I think it's slightly easier. I think this time. Okay, so calculate SE you can get from. So let's say you save it as SE, YF, forecast 57. How many steps again? 4 steps up to 60. Okay, so you have SE from here, okay, SE from here. And then your forecast, you get forecast the last 4. Just now when we calculate, you know, right? This one. So this one for MA, for AR, you just inspect the program again, and then just you refer to the PACF. So this one. So just now. So AR1, AR1. estimate the model. Quick estimate equation. So you have y space c space R1. Okay. So inspect the inverse of the R roots. So it's inside. So in terms of calculation, we say that the model is stationary. Okay, and then you check C2 whether it's adequate or not. And yes, it is adequate model. So this one you have to inspect for instance like because some greater than 0 smaller than 0.05. So if this one just 456 7, like 7. So it is greater than 0.05. So you consider model to be adequate model. But it depends. In this case, if you use the approach, so because this one we have quite small data, so we cannot. It's not reliable to go far from or beyond that one. Although it is also good. If you refer to the online textbook, it suggests that you have seasonal data, then it's better to check or perform the test at least and cover for 1 year. So for example, like that monthly data like 12, for example. Okay, like 12. But this one because we have small data, quite small data, then meaning that beyond that one is not that reliable. Okay, so just now we finished forecast, we estimate model, so calculate manually. So we can consider as adequate, although it's not. Perhaps there is possibility that we can find a better model in terms of that one. For example, just now, if they say you are able to get other model, then also greater than the 0.5 for this part, then I think that was better. But this one, if they say we just inspect up to this one, then we consider to be adequate. Although it's not a very good model. I mean, in terms of because it's 30 bucks. Now this one is less than 0.05. So our estimate is one. So you can calculate manually. The question asks you to calculate manually. So this one, remember for AR, it is the mu bracket 1 minus P1. The intercept, right? For R1, the intercept mu bracket 1 minus P1. But because your P1 is negative, so 1 minus 0.4, it becomes 1 plus. 1 plus 0.4. Okay. So, but you get slightly different. I mean, you calculate, you just produce 33 something. Okay, but we calculate because of decimal place. It's round up to how many 6 decimal place only. So we get slightly different 32 something. Okay. And SE from EViews, and you calculate. So to produce forecast, YF, SE, 57, 60, so you have your forecast value. So as just now, you have this one 33.9. So the one that we calculate, you get 32.8. For MA, quite close, but we are slightly not that far, but also not that close. And then SE, using SE, you can calculate. Alright, and then you look at the answers for the English assignment. Also the same, you can see that the chosen model, this one. when we select model using ETS, using R. So this one basically you can see as short-term forecast, long-term forecast, short-term produce better. Because for long-term forecast now it's quite far, so the chance of having or getting more equal forecast is lesser. But then if you inspect that when you inspect the graph, basically you can see it has trend. But then when we use automatic ETS, automatic model selection, it choose model without trend. So just like before, so sometimes certain data, the model, because they want the model selection is done based on EIC or SIC. So it's like by finding model has model value, so it does not select model based whether it really has trend or seasonal variation. So there was some time. It is good practice that you inspect the graph as well. Do not only rely on this one. Okay, do not rely on the automatic model selection. So even the use of AutoRima as well, you have to AutoRima in R. So the one the additional material that provides you in the spectrum. So when it is good that you complement your decision by looking at inspecting the graph as well. So this one, if you choose model by inspecting the graph, for example, maybe you can choose model with additive trend, for example. So perhaps you produce better forecast. Okay. So in terms of the suggestion, maybe one of the possible suggestion is to identify an appropriate model by inspecting the graph. Okay, not only rely on the AIC and SIC. So this one either one lah. Okay, or if you provide other suggestion that is acceptable, then I give mark as well. Okay, so what else? I just name this next week. Don't forget. So I will not give the replacement quiz. You don't come next week, 0 lah for that 10%. Okay. So even you don't feel well, you just EBCD, right? I mean, you inform me now if I'm able to come, just inform me. Perhaps I will allow you to do it at home if you are able to provide medical certificate, okay, for next week. Because it's just online, so the quiz given online. So next week, on the quiz, you have to use computer. Is computer provided or available? The computer in the computer lab, not your own computer. Okay, so I think that's all today. See you next week for our last lecture. Attendance.